All right, here's our first video, and it's just about key terms. So one of our first key terms here is what is statistics? And I've asked my classes in the past, what are some statistics that you can remember? There are certain things like, increased physical activity increases physical or academic success in K through 6. 30% of college graduates are employed in the same field as a major, or 60 to 70% of SIDS is prevented by using pacifiers during naps. The average engagement ring is at least 1 carat. The probability of being hit by lightning is greater than the probability of winning a Powerball. That's probably probability. It's a little bit of statistics. Cancer is the leading cause of death is for Hispanics. 19% of Americans are physically active. Females have a higher chance of finishing their college degrees than males. Now, these are all statistics that they came up with. We'd have to actually look them up and see if those are true. Those are just ones that I wrote down from studies. But what do these all have in common? Well, let's just Google what is statistics. It says something about the practice or science of collecting and analyzing numerical data. By the way, I think it could be other data too, in large quantities for the purpose of inferring proportions in a whole from those in a representative sample. So the Google definition isn't necessarily the best definition, but basically statistics is the science of designing some sort of experiment to answer a question like, can pacifiers prevent SIDS, sudden infant death syndrome? Or what is the leading cause of death in the Central Valley? How many hospitals will we need? What are the factors for students in finish a degree, etc. So design experiments, collect the data. We can't ask every student in the United States, so we're going to probably take a sample from that population. We summarize the information, and this just helps us understand and sort of digest the data and to draw conclusions, see patterns. We use this sometimes to estimate whatever present values there are or predict the future values. One of the coolest things about statistics, it's a math class, but you can apply statistics in science and social science, business, astronomy, biology, education, engineering, genetics, marketing. Just the data science out there is incredible. And of course, medicine, psychology, health, and sports. Everybody's heard of Moneyball and how they use statistics to help hire for the A's, and it worked. So John Tukey says, the best thing about being a statistician is that you get to play in everyone else's backyard. So we can answer questions. How many hospitals are needed? What kind of services should be provided? To whom should we be marketing? Does this drug work? Can a dog see color? Which glue works best on plastics? Good one. What kind of sentencing should criminals be given? In other words, what are the key factors which are correlated to recidivism? Is there a gender gap in pay? And if so, in which careers is there a gender gap? Which is it bigger? Which is it smaller? Is it reversed in any careers? So many questions. I mean, these things affect us all the time. People not being able to smoke in buildings because secondhand smoke is correlated to cancer. Did they find everybody who was actually affected by secondhand smoke? No, but we can use statistics to find that sort of correlation. So evidence between exposure to sunlight and skin cancer was made by an Australian statistician, Oliver Lancaster. Okay, now to get to the fun part, vocabulary. So we're going to collect data. Data is just a collection of observations, and it could be, there are these so many types of dogs, so many Yorkshire Terriers and Rottweilers and Golden Retrievers. You could be collecting weights, you could be collecting gender, etc. So it doesn't have to be numerical. Data is both quantitative and qualitative. We'll get into that in a minute. And by the way, all of those topics I was just discussing, like the type of dog, the breed of the dog, or the length of their hair, or their weight, those are all variables. It's some sort of characteristic. It's either a number, quantity, or a characteristic that you can measure. We can actually, either quantify or categorize those. If I wanted to measure the unemployment rate, I am interested in a certain group of people in the United States, not just everybody, because my 10-year-old is not unemployed. Neither are my parents, who are both retired. We don't consider them unemployed. They're retired or they're too young to work. So we're only really interested in the workforce. And every individual in the United States workforce is the population of interest, if I were considering the unemployment rate. Of course, we can't ask every single millions and millions of individuals in the population of not just the U.S. population here. Remember, this is the population for my study, which is the workforce of the United States. We can't ask the entire workforce. So we would have to take a sample, just a group of individuals that would participate in our study. Of course, we want to be careful of how we sample. We wouldn't just want to ask 100 people in Fresno. That wouldn't be representative of the United States. So we'll talk about sampling in a video later on. If I collect data on my sample, then I might be interested in, for example, the average age of the unemployed people versus the average age of the employed people. Let's say the average age of the unemployed is 42.3. Now, if I only get that, if I only calculated the average or the mean from my sample of people that I collected, that average, that 42.3, that's a statistic. It may be estimating the parameter. The parameter is if I was actually measuring every single person, asking the age of every single person in the workforce, millions of people. That's the parameter, and that's a key difference. It may seem like a minor difference right now, like, okay, so you're looking at the average age of these couple thousand people that you looked at instead of the few million, but that's going to be key in our study of statistics, which is we are going to take a statistic and try and infer something about the population. We're going to try and infer something about the actual mean age of everyone in the workforce. If I actually asked everyone in the workforce, that would be a census, and of course a sample is a subcollection of the data from the population. So I'm going to collect data, and I'm going to collect actually all sorts of data. Some may be gender, age, ethnicity, some may be location, what educational attainment, etc. There are two main categories in which this data falls, and one is called qualitative and one is quantitative. Qualitative is like quality. It's categorical. It's like a name. It may be the dog breed that we're looking at. If we're looking at dogs, it may be ethnicity. That's categorical. There's no sort of number associated with that. The measurement is that I can put it into some sort of categories. Quantitative is a measurement using a number. So, it may be your last year's salary. That's quantitative data. It may be age. That's quantitative data. It's an actual some kind of numerical measurement. So this is also a fun part because we can split up data even further. And then you might say, why do we care about all these levels of measurement? Well, if you actually go a lot further in statistics and even just a little bit further into this class, you will need to know what type of data you have in order to understand which type of statistical test to use. So just be aware of that, and for now, memorize your vocabulary. Nominal, it's like a name, it's categorical, it's also kind of the same as qualitative, except you can also have sort of a qualitative where you could put in ranks. So most qualitative data cannot be ranked. For example, what's your major? And you go, oh, well, economics must be better than math. Well, that's not exactly how it works. You just say your major and you're put into those categories. However, ordinal could be something like strongly agree, disagree, strongly disagree. You can, military rank is another one. Quantitative can be two types. And one is interval and one is ratio. And again, why are these important? Really later on in statistics, but for now know that there's really only a couple types of interval variables. and that is stuff like temperature, time of day. So there's sort of no inherent zero, but responses can be subtracted. Like the temperature went up by 20 degrees. You have to know, okay, is that 20 degrees Fahrenheit or 20 degrees Celsius? But whatever scale you're on, that you can subtract or add, and it makes sense. So, but it wouldn't make, if you said it's twice as hot, that would be questionable. So a ratio is really most measurements that we use. For example, age, height, distance, time measured in seconds or something like that. So it makes sense to say 10% more or twice as much. Another important distinction for data is, especially quantitative data, in fact only quantitative data, is the difference between discrete and continuous data. So for example, number of children, if that's your variable, the data is discrete. You can't have 2.46 children. You might have 2 children or 3 children, but they're countable. The number of people in the room, the number of TVs in a house, the number of cars. You don't have 3.5 cars. You either have 3 cars or 4 cars or no cars, right? But it's still countable. Continuous might be the gallons of gasoline. Now, you may know that you may only see a certain level that's being measured when you fill up your car with gasoline. It may go to 2 decimal places of the number of gallons, and you might say, oh, well, there's a countable number of gallons, but really it could be, even if it says 2.46 gallons or 12.46 gallons, it might be 12.4, it's somewhere between 12.46 and 12.45, or someplace between 12.46. In other words, between every 2 numbers, there might be another number there. There is another number that so volume, measurement and volume, weight. Even though your scale might not be that precise, weight is a continuous variable. Volume is continuous variable. You can count the number of leaves on the tree, but the height will be continuous. And when you think about height of a tree or the height of a growing boy or girl, it is continuous. It's not, between every 2 heights. They don't skip 2 heights. They actually grow in between that. It doesn't have to be continuously growing or continuously changing, but the variable, that's the idea, variable is continuous. Have a great day and study your vocabulary. Bye.